Have you ever stopped to think that information itself might actually have a shape? I mean, that the whole world of data and statistics isn't just a bunch of numbers in a spreadsheet, but a rich geometric landscape, a place with its own version of distance, its own kind of straight lines, and even its own curves. It's a wild idea, right? Well, today we're going to dive right into it and explore the hidden world of information geometry. So, here's our game plan. We're going to start with the simple geometry we all know and love. Then we'll take a leap into this new world of information. We'll check out the special tools we need to get around in this space, uncover a really surprising and powerful property called duality, and then we'll see why any of this actually matters for stuff like machine learning.
All right, first up, let's start on solid ground. Section 1, the geometry of everyday life.
Let's start with a super simple question, one you already know the answer to. If you want to get from point A to point B on a flat map, what's the most direct route you can take?
A straight line. Of course, it's totally intuitive. This simple fact is the whole foundation of Euclidean geometry. You know, the system we use to navigate our physical world every day. So the idea of points and straight lines, that's our anchor. Now, hang on to that idea because we're about to take it somewhere completely different.
Let's move on to Section 2, a new world of information. This is where we go from physical maps to, well, abstract models.
So what if we're not dealing with cities on a map anymore? What if our points are actually statistical models? You know, like two different bell curves. What in the world is the shortest path between them?
This is where we do a little translation. In this new world, a point is now a statistical model. The map that all these models live on, that's called an information manifold. And our good old straight line, well, that becomes something called a geodesic, which is just the fancy word for the shortest path on this new and often curvy landscape. So what exactly is this information manifold? Okay, think of it like the surface of the Earth. Globally, we know it's a sphere. It's curved. But if you just look at your neighborhood, it seems totally flat, right? An information manifold is the exact same idea. It's this whole space of models that, on a small enough scale, acts just like the simple flat space we're used to. It's our new map for navigating data. Now, to find our way around in this new world, our old tools just won't cut it. And that brings us to Section 3, the geometric toolkit. First thing we need is a ruler. In information geometry, that's the metric tensor, or more specifically, the Fisher information metric. This is a really powerful tool that lets us measure the distance between two statistical models that are super close to each other. It basically tells us how different they are based on the data they might create. Okay, next up, we need a compass, something to tell us which way is straight. This is the affine connection. It's basically a set of rules that defines what a geodesic, our new kind of straight line, actually looks like on the curved surface of our information manifold. It's what lets us compare directions at different spots on our map, making sure our path is really the shortest one.
All right, we've got our map, we've got our tools. But this is where information geometry shows us its most unique and powerful secret. Section 4, a surprising duality. So, what is it? What makes this whole geometric framework so different from the familiar world of spheres and planes we learned about in school? What's the secret sauce?
The answer, in a word, is duality. See, in our standard geometry, a straight line is a straight line. That's it. But in information geometry, there are two of them. We get this pair of what are called conjugate connections. It means that for any of these information maps, there's a primary way of defining straight and a second, totally complementary, dual way of defining it.
And this is where it gets really cool. When a manifold is flat according to both of these definitions at the same time, we call it a dually flat manifold. These spaces are incredible generalizations of the simple flat space we started with. They have two coordinate systems built right in, and they're linked together in this really beautiful complementary way.
One of the most amazing results of all this duality is a brand new kind of Pythagorean theorem. In this space, you can actually have a right-angled triangle where one side is straight according to the first rule, and the other side is straight according to the second, dual rule. I know, it sounds a little mind-bending, but this unique property lets us solve problems in a much more elegant and powerful way. So I know this is all fascinating theory, but you might be thinking, what's the payoff? Why does any of this matter? Let's get into our final section and see the real-world impact.
Yeah, understanding the shape of information isn't just some academic thought experiment. It actually helps us design smarter, way more efficient machine learning algorithms. For instance, an algorithm called natural gradient descent uses this geometry to find the true steepest path to improve a model, which often means it can learn much, much faster. It also gives us deeper insights into things like data clustering and how to test scientific hypotheses.
The pioneer of this entire field, Shunichi Amari, said it perfectly. Information geometry is a method of exploring the world of information by means of modern geometry. It just gives us this whole new lens, a new language, to see and understand the fundamental structures that are hiding inside our data. And that kind of leaves us with a final thought to chew on. We have just barely scratched the surface here, learning that this world of probability has a rich, beautiful shape. So the question becomes, if information really does have a geometry, what other profound secrets about how we learn, how we reason, and maybe even about intelligence itself are just waiting to be discovered?